So in this lesson, we're going to talk about algebraic expressions and how we evaluate them and how we simplify algebraic expressions. So we're going to first look at these three examples where it gives us an algebraic expression in a phrase. And we're going to come up with an algebra expression that models the phrase. So when I read, I'm looking at letter A, when I read 7 fewer than a number t, fewer than means is less than, and is less than means we're going to subtract. So 7 fewer than a number t would be the number t minus 7. That's an algebraic expression made up of numbers, symbols, and variables. 2 times the sum of a and b. 2 times the sum means we're going to add. So we want the sum of a and b. So I'm going to add a plus b, and then I want 2 times the sum. So we want 2 times that whole expression. So we want 2 times the whole thing, a and b. The last one says you start with $20 and you save $6 each week. So what algebraic expression models the total amount that you save? So if we start with $20 and we save $6 each week, you're saving money, so you're adding that to what you already have. So saving $6 each week would mean 6 times x, where x is how many weeks. So we can translate phrases into algebraic expressions. So we're going to put that phrases get translated into expressions. And then we'll eventually look at sentences later that get translated into equations. So we're going to now look at some algebraic expressions and talk about how we evaluate them. Evaluate means to find the value of. If we know the value of variables, in other words, if we know what a is, how many a is equal to, or how many b is equal to, then we can evaluate the expression. And in order to evaluate the expressions, we need to remember our order of operations. So I'm going to first plug in that a is -4 and that b is 5. And then I'm going to use my order of operations to evaluate. I know that I always do parentheses or grouping symbols first. So -4 plus 4 is 0. And then I always do multiplication and division before addition and subtraction. So I see 7 times 0, which is 0. 3 times 5, which is 15. Oops. And -8. So now then when I finally get down to where all I have left is addition and subtraction, I'm going to go left to right. Addition and subtraction, left to right. So 0 plus 15 is 15, and 15 minus 8 is 7. So the value of that expression is 7. All right, so let's look at the next one. If x is equal to 1 and y is 1/2, then we're going to do our order of operations now. I'm going to do exponents before I add. So 1/2 squared, we know that to square a number means to multiply it by itself. So 1/2 times 1/2 would be 1/4. Then I have to add 1/2 plus 1/4. And I know that 1/2 plus 1/4 is 3/4. So the value of the expression is 3/4. And then lastly, we're going to plug in 6 for x. We need to do that. Minus -3 for y. So we have to be careful here. We've got a bunch of grouping symbols going on here. Because I noticed I put the -3 inside parentheses to square it. So that's going to remind me that I square the -3, not just the 3. So let's see. This big fraction bar right here is a grouping symbol. So when I see a fraction bar as a big grouping symbol, I know I'm going to do everything in the numerator first and before I divide. And then in the numerator, I've got some parentheses going on. So I'm going to do 6 squared, which is 36, minus negative 3 squared, which is positive 9. Notice when I square the negative, it becomes positive. And then I've got to do grouping symbols first, parentheses before multiplication. 36 minus 9 is 27. And then I'm going to multiply. 2 times 27 is 54. And 54 divided by 3, we're going to check on our calculator just to be sure. 54 divided by 3 is 18. So the value of the expression is 18. So we're going to have to remember, in order to evaluate expressions, we have to remember order of operations. Okay, an expression that is a number, a variable, or the product of a number and one or more variables is called a term. A coefficient is the numerical factor of the term. So for example, 5x is a term. The 5 is the coefficient. A constant term is a term with no variables. So for instance, 10. 10 is an expression with no variables. That is called a constant term. A constant is a number. Like terms have the same variable raised to the same powers. For example, 3x squared and 5x squared are like terms because they have the same variable all raised to the same power. Notice their coefficients are different. When we add like terms, we add the coefficients and the variable part stays the same. We'll talk about that in just a second. So we've got all these properties dealing with expressions that we're just going to run through. The definition of subtraction is when you subtract, you add the opposite. That's what that first one's saying. And the next one is saying when you divide, you're basically multiplying by the reciprocal. So a divided by b is the same thing as a times 1 over b. So when you subtract, you add the opposite. When you divide, you multiply by the reciprocal. And that goes with what we were talking about with the additive identity and the additive inverse, and the multiplicative inverse property. The definition, distributive property, we've already talked about distributive property, works for addition and subtraction. When we multiply by 0, we get 0. We multiply by negative 1. All it does is change the sign. We know that. So that's going to be something that comes up a lot this year. That when we multiply something, no matter what it is, by negative 1, it just changes the sign. And then all of the next ones are pretty straightforward. The opposite of a sum would change the sign of each term. So if you make the a and the b both negative, multiply it both by negative 1, it changes the sign. And when you multiply a minus b times negative 1, then it changes the sign again. So the a becomes negative, the negative b becomes positive. And another thing that's good to remember is that negative a plus b is the same thing as b minus a. Okay, and then the opposite of an opposite changes it back to positive. Okay, so all these little tidbits that we need to remember from algebra. So the last two examples, we're just going to simplify the expression. Notice we cannot evaluate these expressions because we do not have a value for the variables. All we can do is simplify. So by simplifying, we distribute and we add like terms. So by simplifying, let's remember always, we distribute and then we add like terms. So let's see, we're going to find our like terms in letter A, 7x squared and minus 4x squared. 7x squared and minus 4x squared are like terms. So that would be 3x squared. Notice I combined the coefficients and I kept the variable part the same. And then I have 3y squared and 2y squared, which is 5y squared. Same thing. I added the coefficients. The variable part stays the same. Okay, and then letter B, same thing here. We need to distribute. We have a negative 1 to distribute. So we're going to distribute our negative 1. Negative 1 times 3k would be negative 3k. Negative 1 times m would be negative m. And then I'm going to distribute the 2 here to this set of parentheses here. 2 times k would be 2k, minus 2 times 4m would be 8m. And then after I distribute, I always look for like terms. So I see negative 3k plus 2k, which is negative 1k. Notice, once again, I added the coefficients. The variable part stays the same. And then I've got negative m and negative 8m. So negative 1 plus negative 8 would be negative 9m. And that's all I can do.